With our blockchain API, we can now interact with one blockchain as a single user, seeing its blocks and mining new ones. However, in order to create a truly robust blockchain system, we'll want to support the collaboration between multiple collaborators in the blockchain. To accomplish this, we'll set a peer-to-peer server that connects multiple users running this blockchain application. In this setup, every individual running the blockchain application will be considered a peer. The first peer, to start the application, opens and starts the peer-to-peer server. We'll use a technology called WebSockets for this peer-to-peer server, which allows us to set up a virtually real-time connection between multiple nodes running a Node.js application. It will open up a port where it will listen for WebSocket connections. As other nodes fire up the application, they will start up their own WebSocket servers too. But more importantly, they now connect to the original server through that open WebSocket port. Likewise, the original server detects that new instances of the application have attempted to connect to its WebSocket server, and thus it makes a connection over the WebSocket port to those new instances. Overall, through this connection, all the connected peers have the ability to broadcast data through stringified messages to all the other connected peers. This is convenient for us, because as each new peer connects to our blockchain application, we need to ensure that the peer has the updated blockchain. Plus, as new blocks are added by one peer, they will have the ability to broadcast that change in the data of the block to all the connected peers over the WebSocket connection. As we create this peer-to-peer server, note that there are two possibilities for how an individual server will behave. First, as the initial instance of the blockchain application, this node will start the first peer-to-peer server, and then it will wait for connections as its peers' applications start up. As a second, third, or even later instance of a blockchain application, this node will connect to the original peer-to-peer server done in step 1 and connect over a designated WebSocket port. We won't have two separate classes for both of these functionalities. In our implementation, our one peer-to-peer server itself will have both the capability to do part 1 and part 2. However, it will know whether or not to open the first server or to connect to peers immediately based on us providing an environment variable that we specify for the server on what peers that it has. So with that, let's start creating this peer-to-peer server so that we can have multiple contributors to our updating blockchain application.